We also have link and expand, which should only be used when you truly need it. Link and expand increases the number of rows in the base table, duplicating records to match rows in the foreign table. If the link key columns for a record in the base table have 4 matches in the foreign table, the base table record will be replicated 4 times with link and expand. This operates similarly to a Cartesian product. Link and expand is an extremely expensive operation in terms of query performance and memory utilization. It's almost never necessary to use link and expand. Think through your problem and you'll likely find a faster approach. In this example, we have a retail transaction fact table at line item granularity, and a dimensional table containing master data for each store. We want all sales transactions that occurred in Texas. One approach is to start with the store table and use link and expand as shown here. This approach goes against guiding principles by starting with the much smaller stores table and linking in the larger fact table. As a best practice, we want to start with the larger table and link in the smaller table. It also uses link and expand to work around having many transaction records for each store. Using the store table as the base table means we need to expand each store record to match the number of transactions in that store. Let's look under the hood. In link and expand, we start with a stores table. Segment target size is 8 million records. If we have less than 8 million stores, we have all data in a single segment. Each segment is associated to one sub-process. By starting with a small table and linking in a large table, we get an undesirable processing model. The single sub-process associated with one segment store table must scan through the much larger fact table. We've fully removed the benefit of parallel processing. The sales table has many segments and sub-processes. By starting here, the link can be performed in parallel by multiple sub-processes, fully leveraging the platform. Most often, we link in tables to access field values from the foreign table. In link and expand, the access from the store table to the sales table is highly randomized. Random data access is slower than sequential access. Random data access across large quantities of data is even slower. By starting with the sales table, our access pattern on the sales data becomes sequential, resulting in better performance. This is complicated, with very poor performance. Let's do better. By starting with the transactional fact table and linking in the store table, we avoid link and expand. We know the stores table is small, so we use a worksheet linked to simplify the query and filter data to only transactions that occurred in Texas. This approach is easier to write and executes faster. Finding a solution that doesn't use link and expand will be simpler to maintain and perform better.